an envelope, and a spaceship? And the answer is actually sitting in the audience amongst you right now. We have Dr. Qing and his colleague Alan Lee, which created the Terahertz quantum cascade laser at MIT. And I should have mentioned this to you beforehand, but I'm going to call him out. Dr. Hu is sitting right here in the audience, and I'm going to say you can ask him questions if you'd like afterwards. But he invented this laser, and we'll go step by step what this laser actually is, because I'm a molecular biologist, and I didn't really know much about what this meant when I was making this presentation. He explained it to me very, very well, so I'm going to try and do the same for you. So let's break it down and start with a terahertz laser, and what that means to say terahertz. Well, it's something that emits light. Now, we have things all around us that's emitting things in the visible light spectrum. We've got our light bulbs all over the place. How many of you have something that emits microwaves at home? You know something that emits microwaves at home? I assume most people have a microwave. It's emitting microwaves. So we can make things that emit microwaves. How about, have you ever seen anything that emits X-rays? Maybe not in your home, maybe in your doctor's office, something that emits X-rays? Yeah, we can make things that emit X-rays. It's really hard, though, to make something that can emit light in the terahertz range. It's this near infrared or far infrared range in here called the terahertz gap. And the reason we'd like to be able to emit things here is because when we visualize things in this range, we can see through things like envelopes, skin cancer, and spacecraft. So we're talking about making something that emits light in this terahertz range. Now, he did it with something called a QCL, a quantum cascade laser. Again, something very tiny, size of a quarter. What it means, well, a laser is something that emits light, in this case in the terahertz range. Quantum meaning very, very, very small, on the quantum scale, very, very tiny scale. So that's where all this is happening. And cascade is how the process actually works to do that, where a visible light is put through repeating materials of different thicknesses, so different types of materials, repeating thicknesses, and when it comes out on the other side, it's in the terahertz range. So a quantum cascade laser that emits in the terahertz range. Now, it would be great if these things could function at room temperature, like you have any type of, laser pointer, or if you have anything that emits light, it'd be nice to do it at room temperature. If absolute zero is minus 460, the commercially available kind is emitting this light at minus 370. So most of any of the emitters has to have this giant cooling unit associated with it. Right now it's been experimentally done at minus 100, that really hot minus 100 degrees Fahrenheit. And the goal obviously being working on it at room temperature. Now also, when I asked about what else this new quantum cascade laser was able to do, he said it has more power and more focus. I said, well, why do you want more power and focus? He said, because it's a laser. When you have a laser, you want it to be more powerful and more focused. So also on here, and then one of the other big steps that this particular laser can do is it can emit in different wavelengths in that terahertz range, kind of like you're able to tune the dial on a radio and change the different wavelengths on that. Well, this particular emitter can actually emit in changing different wavelengths within that terahertz range that's in there. So that means you're not stuck with just one particular wavelength, but you can use different ones depending on what it is you want to visualize with it. So here is Envelope the movie, which is taking a look at a piece of metal that's inside of an envelope in real time. So it's real-time imaging with this terahertz light. And you can see the metal in the envelope. But that's nothing that new necessarily, because we have an X-ray machine at the airport can see metal inside of something. What's really cool is, have you ever seen kind of one of those old tricks where someone holds the piece of paper up to the forehead and they're like, what's written in here? And they try and think what's written in here. Well, the terahertz laser can be used in order to visualize writing on the inside of an envelope. So here's the web address for this particular lab here. So Envelope the Movie Part 2, much more successful than Envelope the Movie Part 1. And then other applications that it has is, for example, in skin cancer, when you're removing cancerous skin, you want to remove the cancerous part and leave the healthy part. But it's difficult to be able to visualize it while you're doing it, and so they need to make a cut, do a biopsy, make a cut, do a biopsy. This allows you to image where the cancerous cells and the healthy cells are in real time so that you can remove all of the skin cancer in one shot without damaging the rest of the skin around it. Seeing through envelopes, of course, and then NASA's been using this imaging for several years now to see through the outer layer into the insulation layer of certain spacecraft to see if there's been any damage inside, which could compromise the entire spacecraft on liftoff and re-entry. And then our final